Hello scholars, welcome back to week 2. I'm excited to be back with you guys. We're going to be continuing with chapter 2, classifying decimals. Now we already know that we have, with decimals, there are terminating decimals and non-terminating decimals. With our non-terminating decimals, we can have repeating or non-repeating. Okay, but just as a recap, so we have our terminating decimals. These are the ones that just continue on with zeros. They basically just stop where they are. So like 3/4 would be an example of a terminating decimal because 3/4 is the same as 75/100ths. Okay, so it does stop. So that's terminating. Then we have our non-terminating. These are the ones that go on forever. Okay, so non-terminating decimals, you can have the repeating ones, which would be like 1/3. That is a decimal. Well, the decimal would be 33/100ths, or the 3 would just keep on going on and on forever. Now with repeating decimals, those are the decimals that we're going to have the bar notation over. That basically symbolizes that it keeps on going, that it's reoccurring forever. Okay, so the bar notation over the numbers indicates that it keeps on going in that sequence. Okay, now the last branch is non-repeating. Okay, so as a final recap, we started off with terminating, and we also have non-terminating. From our non-terminating, we have our repeating, and now we know that we have our non-repeating. Now with non-repeating decimals, is it possible, I really want you to think about this, is it possible to have a true rational number that is non-terminating and non-repeating? Is it possible to have a rational number that is non-repeating? I want you to think about that as we finish up this chapter. Now for the activity today, you're going to sort signed rational numbers into sets of equivalent rational numbers. Okay, so there's going to be a lot of little boxes, and there's going to be different numbers inside of it, different fractions, all of that. You are going to sort them into equivalent rational numbers. So the focus of this activity is that if the quotient of two integers, so the answer, if the quotient of two integers is negative, the negative sign can be placed in front of the whole fraction, or just in front of the numerator, or just in front of the denominator. But no matter where the negative is placed, whether it's in front of the whole fraction, whether it's only in front of the numerator, or only in front of the denominator, they will all be equivalent. But you only need one negative to make the answer a negative. Now with the activity for today, there will be some cards that are blank, and you will have to fill in the appropriate fraction or decimal to go along with each of the groups that you have created. So you're going to convert the fractions, you're going to finish up all the fractions, you're going to place the negatives in the appropriate places, and then you're going to convert the fraction to a decimal, and you are going to label these groups, each group, as terminating or non-terminating. And for the non-terminating, you're going to state if it's repeating or non-repeating. And remember that question that I asked you earlier. Is it possible to have a rational number that is non-terminating and non-repeating? Is that possible? All right, see y'all in tutoring.